Right, we're going to do these questions. Try 12. This is the questions that you're asked to do on the chapter of quadratic functions from the SLS lesson 1. Right, this photo is taken from this website called iStoppedPhoto.com. Right, the width of the tunnel may not be 10 meter and the height may not be 5 meter, but I think this is a very good example, a real life example, right, of a tunnel that can be modeled by a quadratic functions, which is the questions that we are asked required to solve in try 12. Right, so in part 1, we are asked to write a quadratic function in the form, this is called the intercept form, to represent the opening of the tunnel. Right. Okay, so the important part is this portion here. How do you find the intercepts? So the questions you have to ask yourself is from the graph, how are you able to find the x-intercepts? So if you look at the diagram carefully, right, on the x-intercepts, there are actually two intersection points here. One of them is your origin, which is 0, 0. That means x coordinate is 0, y coordinate is 0. There's another point here, which is 10, 0. So therefore, your two x-intercepts the two x-intercepts are x equals to 0 and x equals to 10, right? So how can we make use of these two informations to substitute into the equations? Let's try. So I will have y equals to a, right, x minus 0 and x minus 10. So if you simplify further, you would have x minus 0 will give you x, and x minus 10 will be x minus 10. So if you were to examine this quadratic function, there is still an unknown, which is the constant a, and you need to find. So if you go back to the diagram, right, it's quite easy to observe that in this quadratic function, in this tunnel, there is actually a maximum point. And the maximum point is this point here, right? And how do you find the point? Right. So if you were to recall, the line of symmetry will pass through the maximum or minimum point. And the line of symmetry is actually, to find the line of symmetry, it's line of symmetry is to take your two x-intercepts, add them together, and divide by 2. And that gives you x equals to 5. So therefore, the x coordinate of your maximum point is 5. And if you look at the diagram carefully, the maximum height of the tunnel is 5 meters. Hence, the y coordinates of your maximum point is 5. So with that point, you can actually substitute into your quadratic function to find the unknowns, to find the constants a, which is what we're going to do now. And you end up getting negative 25a equals to 5. So to find a, you just take 5 divided by negative 25. That gives you negative 1/5. Right, so with the values of a, you can substitute back into the quadratic functions 1. Right. So therefore, the quadratic functions will be y equals to negative 1/5 multiplied by x bracket x minus 10. Right, so we have found the equations of the quadratic function earlier on, which is y equals to negative 1/5 x multiplied with x minus 10. So the second part of the question is, you're told that there's a point on the opening of a tunnel, and that point is 2 meters horizontally from one end. So what is the height of the tunnel at this point? Right. So horizontally from one end, 2 meters. Right. So probably, okay, so from here to here, it's 5 meters, right? Because we're talking about this this one, it's the maximum point, and we found it earlier on to be 5,5. Right. So therefore, this distance here will be 5 meters from the origin to the line of symmetry, and then this will also be 5 meters. So therefore, 2 meters probably is roughly here. 2 meters. 2 meters will be somewhere here. And we have a point here, okay, which is 2 meters. Right. And the questions asked, what is the height of the tunnel at this point? So what the questions require you to find will be this value here. This one. This is the one that you're asked to find. Right. So if x represents the distance measured horizontally, right, so all you need to do is just to substitute x equals to 2 into your quadratic function. And let's see what you get. So y will represent the height of the tunnel, right? Y represent the vertical distance, which is the height of the tunnel. So you will have negative 1/5 multiplies with 2, bracket 2 minus 10. And this, you can use your calculator to work this out. And you will get 3.2 meter. So therefore, when x is equals to 2 meter, the height of the tunnel right at x equals to 2 meter is 3.2 meter. Right, let's look at part 3. So part 3, what the question is asking is, you have another point, but in this case now, the point is vertically from the base. It's 4.2 meter vertically from the base. And you asked to find the width of the tunnel at this point. Right, so 4.2 vertically from the base. If from here to here it's 5 meter, so 4.2 probably will be somewhere here. Right. So what the questions require you to find will be this distance. This is the distance that the questions is interested in. Right, so first thing first, let's write down the equations of your quadratic function, which is y equals to -1/5 multiplied with x bracket x minus 10. And we're going to substitute y to be 4.2. Let's see what happened. Right, so I'm going to divide 4.2 with -1/5. Again, this one you can easily use the calculator to help you work out the answer. And you will get -21. Right, so what you're getting is a quadratic equation where you need to factorize it. Right, and you will have x is equals to 3 or x is equals to 7. So what does it mean by x is equals to 3 or x equals to 7? Right, so if you go back and look at the diagram, right, when the point is 4.2 meter vertically from the base, right, you will have the first x-intercept here, from here to here. What we are saying is that is 3 meter. Right, there's also another point on the tunnel, which is also 4.2 meter vertically from the base. And that is the point there. So what happened is, when it's 4.2 meter vertically from the base for the second point, your horizontal distance here, it's 7 meter. And what we are interested to find is this distance here, which corresponds to this distance. Early on, that we said we're interested to find. Right. So how are you able to find the distance that is marked in yellow? Right. So quite easily, the width of the tunnel at this point would just be 7 minus 3 equals to 4 meter.